Today we are going to talk about ketone bodies. What are ketone bodies? Ketone bodies are water-soluble molecules which contain ketone group. Ketone bodies are formed in the body in two conditions, which are diabetes and starvation. What are ketone bodies? Which are acetoacetate, beta-hydroxybutyrate, and acetone. Out of these, acetoacetate is the primary ketone bodies, while beta-hydroxybutyrate and acetone are secondary ketone bodies. This beta-hydroxybutyrate does not contain true ketone group, so it is not true ketone bodies. And this acetone is not used for energy production inside the body. As beta-hydroxybutyrate doesn't contain ketone body, we know that ketone group in urine is detected by Rother's test. Beta-hydroxybutyrate cannot be detected by Rother's test because it doesn't contain true ketone body. Okay. Now let us study the formation of ketone body production. That is ketogenesis. Ketogenesis. Ketone body are formed from acetyl coenzyme A. Acetyl coenzyme A combined with another molecule of acetyl coenzyme A in presence of enzyme thiolase to form acetoacetyl coenzyme A. This acetoacetyl coenzyme A adds another molecule of acetyl coenzyme A in presence of enzyme HMG-CoA synthase to form HMG-CoA 3-hydroxymethyl glutaryl coenzyme A. That is, HMG-CoA is formed by HMG-CoA synthase by adding acetyl coenzyme A to acetoacetyl coenzyme A. Now, this HMG-CoA is converted to acetoacetate in presence of enzyme HMG-CoA lyase. This is HMG-CoA synthase which form HMG-CoA, and this is HMG-CoA lyase which degrade HMG-CoA to acetoacetate, and acetyl coenzyme is released. Now, this acetoacetate is the primary ketone body. This acetoacetate is now converted to beta-hydroxybutyrate by an enzyme beta-hydroxybutyrate dehydrogenase. Also, this acetoacetate undergoes spontaneous decarboxylation to form acetone, which is lost in breathing. Okay. Now, I have already told that three ketone bodies: acetoacetate, beta-hydroxybutyrate, and acetone. Out of this, beta-hydroxybutyrate is not true ketone bodies and not detected by Rother's test. Acetoacetate is primary ketone body. These two are secondary ketone bodies. Now, what is ketonuria? Loss of ketone body in urine. Ketonuria, that is ketone body in urine. Ketone bodies are soluble in water, so they do not need any transport medium in blood. Heart and renal cortex utilize ketone bodies as source of fuel, but skeletal muscle and brain utilize ketone body as alternate source of energy. Now, once ketone bodies are formed, they must be used for energy, so that there must be breakdown of ketone bodies by a process called ketolysis. Now, this beta-hydroxybutyrate is converted to acetoacetate in presence of enzyme beta-hydroxybutyrate dehydrogenase, and one molecule of NAD is converted to NADS and H+. Now, this acetoacetate is converted to acetoacetyl coenzyme A by an enzyme thiophorase, which is present only in extrahepatic tissue but not present in liver. So, liver cell cannot utilize ketone bodies. That is, liver cell cannot do ketolysis. If liver cell has had ability to do ketolysis, then the formed ketone body may have undergoes spontaneous ketolysis. That is, there is no any function of ketone body, so that nature has provided that there is no thiophorase in liver so that it cannot cause ketolysis. Now, this acetoacetate converted to acetoacetyl coenzyme A by thiophorase enzyme. This acetoacetyl coenzyme A is converted to acetyl coenzyme A, two molecules, in presence of thiolase enzyme. Now, this acetyl coenzyme A undergoes tissue cycle to form 12 molecule of ATP. This acetyl coenzyme undergoes tissue cycle to form 12 molecule of ATP. But look here, succinyl-CoA is converted to succinate here for conversion of acetoacetate to acetoacetyl coenzyme A, so that normally tissue cycle produces 12 ATP in each cycle. Okay. During this process, one GTP molecule is formed, but when we use succinyl-CoA here, there is no formation of GTP, so that the total energy production is not 24, but it is only 23. Okay. If we are asked total energy production from beta hydroxybutyrate, then we have to add 3 ATP because there is formation of NADH plus H plus, okay, which form 3 ATP. Ketone body formation in alcoholics. Why there is common in formation of ketone body in alcoholics? As we know, alcohol produces large amount of NADH, which interacts with oxaloacetate to form malate, so that oxaloacetate cannot be directed to tissue cycle. That's why acetyl coenzyme is shunted to ketogenesis. Let us study ketogenic amino acid. Amino acid that form ketone bodies are called ketogenic amino acid. We can remember this as only purely ketogenic, that is L. Okay, lysine, leucine, only purely ketogenic. Now both ketogenic and glucogenic amino acid that can form both ketone bodies and glucose are called both. Now we know that PTT are aromatic amino acid, and also I include, okay, phenylalanine, tyrosine and tryptophan and also isoleucine are both ketogenic and glucogenic amino acid. Now for glucogenic amino acid, all remaining 14 amino acids are glucogenic amino acid, but we have to remember some 2 to 3 amino acids. Okay, for this we can remember this as I met his Valentine, who is very sweet, for glucogenic amino acid. Methionine, histidine, valine are glucogenic amino acids. Let us revise ketogenesis and ketolysis. Okay, ketogenesis, formation of ketone body. Acetyl coenzyme, two molecules combine together to form acetyl coenzyme in presence of thiolase. This acetoacetyl coenzyme is converted to HMG-CoA in presence of HMG-CoA synthase. This is the rate limiting enzyme. This HMG coenzyme A is converted to acetoacetate in presence of HMG coenzyme A lyase. This acetoacetate is the primary ketone body, and acetoacetate is converted to beta hydroxybutyrate in presence of beta hydroxybutyrate dehydrogenase. This beta hydroxybutyrate is the secondary amino acid, secondary ketone body, and acetoacetate undergoes spontaneous decarboxylation to form acetone, which is also secondary ketone body. This beta hydroxybutyrate doesn't contain two ketone groups, so that it cannot be detected by Rother's test. Now let us discuss ketolysis again. Beta hydroxybutyrate is converted to acetoacetate in presence of beta hydroxybutyrate dehydrogenase. This acetoacetate is converted to acetoacetyl coenzyme in presence of enzyme thiophorase, which is present only in extrahepatic tissue and not in liver. This acetoacetyl coenzyme A is converted to two molecules of acetyl coenzyme A by an enzyme thiolase. For energy production, there is 24 ATP production from tissue cycle, but as there is use of succinyl-CoA and there is no GTP formation from succinyl-CoA here, so that the total energy for production is only 23. If we are asked total energy production by beta hydroxybutyrate, then we have to add 3 ATP, so that total energy production is 26 ATP from beta hydroxybutyrate and 23 from acetate.